Hey, fourth grade, this is Miss Hunt. I miss you all so much. I am going to go over converting fractions into decimals. So I know we started learning this, and I've posted a couple practice problems for you since we've been on this break, but I want you to have a chance to watch this video and then go over this to practice again. So I'm going to play this YouTube video on the next slide. Follow along, and then we will watch, and then we'll go through and do some practice problems.
Okay. In the last section, we learned one of the most important things about fractions. We learned that they're numbers that are written like division problems. We also know that fractions can be used to represent smaller parts of things. Now, since a fraction is just a division problem, if we wanted to, we could go ahead and do the division and get an answer. And that answer would be a regular number that's the value of the fraction. Let's look at this fraction, for example. 10 fifths. That's the same as the division problem, 10 divided by 5. Now we know that 10 divided by 5 is 2, so the value of this fraction is 2. So what's the deal? The value 2 doesn't seem like a smaller part of something. In fact, it seems like 2 of something. I mean, aren't fractions supposed to have a value smaller than 1? Here's the deal. If the top number of a fraction is bigger than the bottom number, then the value of the fraction will be greater than 1. But if the top number is smaller than the bottom number, then the value of the fraction will be smaller than 1. But if we divide a smaller number by a bigger number and get a value that's smaller than 1, then how are we going to write that down like a regular number? I mean, isn't 1 the smallest number we can write? Besides 0. Luckily, the answer is no. You see, we can write values that are smaller than 1 by using something called decimal numbers. To understand how decimal numbers work, let's first review how we write down regular numbers that don't involve fractions. We call those numbers whole numbers. We use whole numbers when we count things, and counting things is very important in math. The system that we count things with is based on the number 10. In fact, it's called base 10. And it uses what we call powers of 10 as the groups or building blocks that we count with. It's probably no surprise that our first building block is 1. And we can get bigger building blocks just by multiplying by 10. So our next building block is 1 times 10, or 10. And the one after that is 10 times 10, or 100. And the one after that is 100 times 10, which is 1,000. I could keep on multiplying by 10 to get bigger and bigger building blocks, but I think I'm going to stop at 1,000 for now. So what am I going to do with all these powers of 10? Well, like I said, they're the building blocks of our counting system. So I'm going to count with them. But before I do that, I should mention 2 more things that our number system needs besides these building blocks. And those 2 things are digits and number places. Digits are just the 10 different symbols we use for counting. You know, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Number places are like little imaginary boxes that can hold just 1 digit at a time. And they're used like counters, to count things. We use 1 number place for each of our building blocks to count how many of each of them we have. For example, let's say I have 2 hundreds. Well, then I just put a 2 in the number place that counts how many hundreds I have. And let's say I have 5 tens. Well, then I put a 5 in the number place that counts tens. And I also have 3 ones. So I put a 3 in the number place that counts ones. Each number place is named for the building block it counts. For example, this number place is called the ones place because it counts ones. This is the tens place because it counts tens. And the hundreds place counts hundreds, and so on. Of course, most of you aren't used to seeing numbers written like this. So let's rearrange our number places to make it look more like we're used to. There. Now you can see that the 2 in the hundreds place, the 5 in the tens place, and the 3 in the ones place all combine to make 253. Oh, and most of the time we don't actually show the number places. They're invisible. There. That's better. Okay, so that's how we use our building blocks, number places, and digits to write any whole number we want to. But this video is about fractions, right? So how are we going to write fractions with this system? A lot of fractions have values smaller than 1, but right now our smallest building block is 1. It looks like we're going to need some smaller building blocks. You remember how we got our other base 10 building blocks. We started with 1 and kept multiplying by 10 to get bigger and bigger building blocks. Well, to get smaller building blocks, all we have to do is start with 1 and keep dividing by 10. Wait,
So we're dividing by
smaller
10,
number
we're
like
getting
one
10
by a bigger
times
number like
smaller.
10? Well, that sounds like a fraction to me.
Exactly.
If we do that, the building block we get will be a fraction, and its value will be 1 part out of 10, or 1/10. And we can use that to write values that are smaller than 1. A good way to see how this new building block fits in with the other ones is to look at a number line. Oh, look, a number line. And it goes from 0 to 10, and it shows our first two building blocks, 1 and 10.
So these right here are
If we
whole
take 10
numbers.
and divide it into 10 equal parts, each of those parts is equal to 1. And if we take 1 and divide it into 10 equal parts, then each of those parts is a tenth.
So now we have a
Now our
fraction
number
because
line
it's
shows
less
three
than
building
one
blocks.
whole.
10, 1, and a tenth. A tenth is a small number. We can get even smaller building blocks if we keep dividing by 10. So let's take 1/10 and divide it into 10 equal parts. This even smaller fraction is called 100th, which is 1 out of 100. And since it's 1 over 100, it would take 100 of them to equal 1. We can see this by taking all 10 of our tenths and dividing each of them into 10 parts. Now, if we count up all of those smaller parts, we'll find that there are 100 of them. We could keep on dividing with our number line to get smaller and smaller building blocks, but I'll show you an even easier way to find them. Let's list the building blocks we have so far. Notice that on this side of the 1, the first building block is 10. And on the other side of the 1, the first building block is 1 over 10. And back on this side, our next building block is 100, and on the other side, it's 1 over 100. Well then, if the next building block on this side is 1,000, what do you suppose the next building block on the other side would be? Yep, you guessed it, 1 over 1,000, or 1,000th. Of course, I could keep on going in either direction, getting powers of 10 that are bigger and bigger whole numbers, or smaller and smaller fractions, but I think these are enough for now. All right, now that we have all these new smaller or fractional building blocks, it means that we can count smaller and smaller parts of things. But to do that, we're going to need a new number place for each of them. This will be called the tenths place because it counts tenths. And this will be the hundredths place because it counts hundredths. And this will be the thousandths place because it counts thousands.
So we've talked about the
To see how the new
THS
number
means
places
that it's a
work,
part of
let's
the
bring
whole.
back our last example digits. 2 hundreds, 5 tens, and 3 ones. But this time, let's add 6 tenths by putting a 6 in the tenths place, and 4 hundredths by putting a 4 in the hundredths place. Now let's put our number places back like we used to seeing them. Uh-oh, looks like there's a problem. This number looks like 25,364, but we only added tiny little fractions to our 253. It can't be that big. Here's our problem. We can't tell which number places which because they all look the same. What we need is a kind of marker that will help us tell them apart. And that marker is called the decimal point. The decimal point is just a dot that we always put right here between the ones place and the tenths
So
place.
the decimal point
That way
says
we always know that the
and.
ones place is on
That's
the
why
right,
I'm
but the
so
decimal
crazy about you guys saying
tenths
and in
place
whole
is on the
numbers.
right.
Haha.
There, that's better. Now our number reads 253.64. That's how you read the decimal point when you get to it. You just say point. So the decimal point is really just the separator between the number places that count whole numbers on this side from the number places that count fractions on this side.
You do not say 253.64. You say 253 and 64 hundredths. It ends in the hundredths place value, so you finish by saying hundredths. If you want to sound like a real mathematician, you do not say 253 and 64. No one will know what that means.
These amounts are greater than 1, and these amounts are smaller than 1. We call numbers that use a decimal point decimal numbers, or decimals for short. So that's how decimal numbers work, and they're important because we use them to convert a fraction from a division problem into a regular number. In the next section, we'll learn how to convert some special fractions into decimals. But before that, let's do a quick review. If we take a fraction and do the division, we'll get an answer. And that answer is called the value of the fraction. Our number system is called base 10. It uses powers of 10 as building blocks for counting, as well as 10 different digits. Number places are like counters that hold one digit at a time and help us count how many of each base 10 building block a number is made of. There are base 10 building blocks, like 1, 10, 100, and 1,000, that help us make really big numbers. There are also very small base 10 building blocks, fractions that are smaller than 1, that help us make really small numbers. These building blocks have names like tenths, hundredths, and thousands. The decimal point is a separator that goes between the number places that count values of 1 or greater from the number places that count.
If you're in my homeroom, you've talked about how over on the left, this is whole number city, and on the right, this is fraction city or decimal city, okay? So the decimal point is kind of the separator between the two.
Values smaller than 1. To make sure you understand how decimals work and how they relate to fractions, be sure to do those exercises. Bet you didn't see that coming, did you?
Learn more at mathantics.com.
Okay, so now we're going to do some practice problems. This first one, let me see if I can... Oh, interesting. Okay, let me come out of here. Okay. This is going to be your problem. So, okay. Coming onto this place value chart, we are going to do 2 tenths. We have 2 tenths as a fraction, and I want to convert it or change it into a decimal. So I have 0 hundreds, 0 tens, 0 ones, and I have 2 tenths. So I would write this like 0 whole numbers because I'm still less than 1. I have 0 whole numbers and then I have 2 tenths, 2 in the tenths place value. The tenths place value is the first digit after the decimal point. This would be 2 tenths. Looking at my next one, I have 6 tenths. So I still don't have any whole numbers yet. So I have 0 and, my decimal point says and I have 6 in the tenths place value. So I would write it like this. That is 0 and 6 tenths. Or you could just say it like 6 tenths. You don't necessarily have to say the 0 and. Our next one is 9 tenths. So if I think about the fraction form of it, I still have less than 1 because I know 10 tenths is 1 whole. So 9 tenths is still less than 1. So I have no wholes and I have a 9 in the tenths place value. So this would be 9 tenths. Now you'll notice that my fraction this time changed a little bit. Okay, it's no longer tenths. My denominator is now hundredths. And if you're in my homeroom, we've repeated over and over and over again. As the denominator gets bigger, what? The pieces get smaller. So if I have hundredths, that means I have a bunch of really, really tiny pieces. So I have 9 tiny pieces here. Now let's think about how that would make a fraction. Well, I don't have any whole numbers yet. I haven't eaten the whole pizza yet. Oh, that's an O. 0 and I do not have any tenths. I don't have any tenths. So I will put a 0 in that place value. And I have a 9 in the hundredths. This number right here says 9 hundredths. It's a 9 in the hundredths place value. 0 and 0, 9. 0 tenths, 9 hundredths. Now, if I were to write 2 hundredths, I still have 0 wholes. And do I have any tenths? No, I do not. So I'll put a 0 there, a placeholder. And do I have any hundredths? Yes, I have 2 hundredths. So this is a lot smaller than 9 hundredths. 2 hundredths is smaller than 9 hundredths. Now, 15 hundredths looks a little bit different. This 5, the end of my number, has to land in the hundredths place value because I have that many hundredths. So if I'm at my 5, I come over here and it needs to land in the hundredths. So I will put a 5, and I'm going, since I can't write on this, I'm going to work my way back. So I have a 5 in the hundredths, but I don't just have 5 hundredths, I have 15. So I'm going to put my 1 there, and I have 0 wholes. So if you were to see this up in this place value chart, it would be 0 and 1 tenth, 5 hundredths would be 15 hundredths. Same thing with 82 hundredths. Now I know 100 hundredths is 1 whole, and so 82 hundredths is getting closer to 1 whole. If I have 100 pieces, I have 82 of them eaten or filled in, okay? So this, I'm not at 1 whole yet, but I do have 82, of them. And now I'm gonna check and make sure that my number, my digits land in this place value. This is, the 8 is in the tenths, the 2 is in the hundredths. So this is 82 hundredths. Now, if I have 100 hundredths, I have 100 pieces of pizza and I eat all 100 of them, that is the same thing as 1 whole. Or if I were to write it as a decimal, I would have 1 whole and 0 tenths, 0 hundredths. I could make those zeros go on forever. I have 0 tenths, 0 hundredths, 0 thousandths, 10 thousandths, 100 thousandths, right? This could go on forever. 1 and nothing extra is just the same thing as 1. And my last one, if I have 101 hundredths, this is kind of a challenge problem. I know that 100 hundredths is 1 whole, so I have 1 here. And I don't have 100 hundredths, I have 101 hundredths. So this is where you could make a number bond and pull out a whole like we've been practicing, but this is the same thing as 1 whole, and I have 1 extra hundredth left. So I don't have any tenths, but I do have 1 extra hundredth. Notice how this number right here says 101. And if you kind of ignore the decimal point, this one also says 101. So my digits are matching in the same spot. Now, your job is to fill in this chart, okay? So this is kind of uniform. It's more like word form. So I want you to practice, fill in this chart, fill in your unit or word form, fill in your fraction form, and then fill in your decimal form. So for example, the first one, we have 1/10. So I would write that in fraction form as 1/10. Okay? If I then wanted to write that as decimal form, I would write 0 wholes and 1/10. That is an example for the first one. Your job is to fill in the rest. Good luck, and please reach out to me or Mr. Morris if you have any questions. We have our office hours posted on our newsletter.